asking questions, then obviously I want to know. So we are talking about maths today and transitioning to AS maths, or transitioning from AS to A2 maths, particularly GCSE to AS, because that's the kind of more scary thing, because you don't know what's going on. And hopefully you can all see my screen. Somebody let me know if you can't see.
Yes, we can.
Good. And basically what students have said to me when I've been teaching is that they just want to be told exactly what they need to do. And I think that is the best description of what we've got with the Tailored Tutor course, is that we just are telling you exactly what you need to do. So taking that pressure off you to work out what you're supposed to be doing. Students often say that they don't know what they don't know. So they don't know what questions to ask because they don't know what it is they don't know. They think they're doing well. They understand the maths lessons. The maths lessons are fine. They go really well. They follow it. And then they try and do their homework and they've got no idea what's going on. So here is my tips for exactly what you need to do in maths to get a really good grade. Firstly, join Tailored Tutors Maths Ultimate Guide so that we can work with you, and then follow the weekly playlist and attend the weekly live classes. There's a try it free coupon code that you can use at the moment, so you can get a month free. And then we're going to go through these, which are my really top 6 things that are going to make a massive difference. Okay. So most important thing, this is the one that you probably won't have heard of and won't really understand what I'm saying, but star A, things my brain said were true, but they are not true, it was lying list. In your head, you're going to have these things that your brain thinks are true, and they think they're true because they seem like they would be true. So for example, the square root of 2 things times together is the square root of this one times the square root of this one. And if you have a fraction and you take the square root, then it's the square root of this one and the square root of this one. So therefore, logically, if you have 2 things added up and you take the square root, then it's going to be the square root of each one added up. It's a simple extension of that rule, but it doesn't work. It's not right. And what you have to do when you're working through your maths and you're learning is you also have to learn what things are in here which are not true. That's really, really important, and it makes such a difference to your work. You would not even believe the difference this will make to your maths. Second years, you can take this on board very quickly, hopefully, because you'll know the impact of those things coming along. And these little slips that happen, they don't happen because you're making a slip. They happen because you're going so fast and you're doing so many things, and your brain is saying, yeah, that's okay, you can put that over there. And you're going, okay, I'll put that over there, but you can't put it over there. That's made up. That's a made up rule. That's lying. You can't put it over there. Now, your job, one of your things that you need to do to get this good grade that you want at the end of next year, the end of the year after, depending on what year you're in, is to collect these things, because your brain won't just say them once. They won't just say that the square root of 2 things added up is the individual square roots added up. They'll say it to you repeatedly. And if every single time you go, no, silly me, they're not, is it? Oh, yeah, no. And you ask someone where you went wrong and they show you where you went wrong, and you go, oh, yeah. Oh yeah, okay. You'll just keep doing it, and you'll do it in the exam as well. And you have to really get these things and find a way to convince your brain that this is not reality. This is not what we can do. This is not true. So I would recommend that you have a folder, one for pure, one for applied, and each of them is going to have 10 dividers in. And each of the pure and the applied has 10 sections in. So you've got these 10 sections down here. And then what you're going to be doing with your section is right at the front, I'm tangling myself in my earphones, right at the front, behind here, a piece of card, or the back even of this piece of card, because it's going to be used a lot and turned a lot. So a piece of paper is no good. And you're going to have that right at the front, and you're going to collect there all the things that your brain said were true, but weren't true. So all of the little minus signs, all of the things where you times it up and it's a fraction and you times it up. By the way, that means literally nothing. Times it up. It's nonsense. You can't times things up. That's not a thing. So that is going to be really, really important. It's going to make a massive difference. Second thing, don't copy homework. What is the point? I mean, literally, there is no point whatsoever other than it gets your teacher off your back. And then if you've got your teacher off your back, then they won't realise that you're not understanding things, and then they won't try and help you, and then that's great, because then at the end of the year you won't be able to do anything and you won't get a good grade. So it feels like a really good short-term solution. And also it can feel, with maths, it can feel like you're not copying, you're asking someone for help and they say, oh, I'll send you a photo of what I did. And then you look at what they did and you go, oh yeah, that makes sense. And you copy it down. And it does feel like maybe you're learning something, but you're not. That learning something in maths, you can feel it. It's like a physical thing joining up. It sort of hurts. And then you go, oh, okay. And suddenly it makes sense. That's what it's like when you actually get it. And when you look at somebody else's work and then go, oh yeah, no, that's not learning and that's not going to help you. So really, really important, don't copy homework. It's putting the problem off, putting the problem off, putting the problem off. Then you're going to get to the end of the year and it's going to be really hard to fix all those problems with not enough time.
Any comments on exam solutions there, Ronnie? I know that the conversation that we had with Claire.
Yeah, exam solutions. So exam solutions is basically the same thing as that. So exam solutions is a really, really good website. The guy has put a huge amount of time. He's done the solutions and they're really good solutions, really clearly explained solutions to all of the exam papers from the last sort of 5 years or so. And so you can go on there and you can have a look, find the question that you're doing, and then you can watch him do it. And it will make sense because he's really good at explaining it. And then you will think that you get it. And you don't. That's not how you learn maths. That's like watching somebody else play the piano and thinking, I get that. I can see what you did there. You pressed those keys in that order. And then thinking, I'll be good for my grade 5 piano exam. No, you won't, because you haven't practiced and developed skills and learned how not to make those little mistakes and all that sort of stuff. So the difference, for example, with the tailored tutors approach at revision time, yeah, of course, we've got all the solutions to all the past paper questions. Of course we have. But the first video that you watch, it doesn't do the question, it talks through the question. So the first video is going to be like, right, what is this question saying? How would we draw a picture of this? What sort of techniques do we need? And then there's a general discussion, one way because it's a video, but general discussion about like, what would we need to do? Okay, so how would the path through this problem look? So first of all, we'd need to find the equation of this. What would we need for that? Well, we'd have to do this, blah, blah, blah. And then at the end, we'd put this and this together and we'd do that. So what you can do is you can watch that and go, oh, okay, yeah, I see. And then you can try it, but you haven't seen the solution. So you're genuinely trying it. You're genuinely pulling those pieces in your brain together yourself and forming those links that are going to then be there in the exam. And when you turn over that paper and you see a question, your brain will go, I know how to do this. We did this before. I can do this. We need to go over here and then over here. And we need to join these things up and do that stuff. So with that, does that make sense, Rich? With exam solutions, is that what you were talking about?
Yeah, definitely. I mean, just watching the piano analogy is great. Like watching somebody do something gives you, I can't remember, I will look it up because I've forgotten this since the beginning of the summer. It's called like perceived competence or something like perceived knowledge. You think that you can do it because you watch someone else do it and you understand when they're showing you, but not, it doesn't mean that you can do it yourself. It's a very, very, very common skill. It's like when you're testing yourself on a flashcard. We produced a whole load of resources last year that was basically how to make flashcards and make them effective. And one of the major issues of drawbacks with using flashcards is that people will put multiple things on one flashcard and they might be able to do 3 out of those 4 definitions, let's say. And then the last one is like, oh, I can't quite get it. And then just have a quick peek. Oh yeah, I did know that. It's like, no, you didn't, because when you couldn't see it, you couldn't do it. Yeah. When you get a visual clue or something that tips you off, then suddenly you can do it. But what do you have that in the exam? No, you don't. You've got to teach yourself how to do these things without those aids. So yes, that's exactly what I was saying.
And this is the thing, is that that everything that is in this course is designed for you to be able to sit in that exam, turn it over and produce answers, know what to do, know what not to do, know exactly what that examiner is asking for when they put that question, and confidently work through that exam, finish in plenty of time and get the grade that you want. And, you know, I think I've got a list here of things to remind me to say about like the course and what I've tried to do in the course, and spiral content, concise content and clear explanations. The explanations in the course, these are based on me having taught this course for 15 years, as well as doing loads of private tuition. And finding ways that really, really work for students and make sense. So there's also the fact that it's really concise. Everything's been pared down to the absolute minimum that you know. In fact, you could do the whole AS using my videos in 11 hours. So the whole thing. And then you will have covered literally everything. Whereas it can seem utterly overwhelming sometimes when you look at like the list of like, and the textbooks, they're like this, and they just, oh, it's huge and it looks terrifying. It's like, I will never be able to get all of this. So what I've done is to just pull it down into exactly what you need to know. This covers it exactly. And then that makes it not overwhelming. It means you can get that picture of what's in the course and quite easily and quite quickly. Also helping with that, we've got template notes. So you don't have to sit there. I've done it myself. I've done Open University maths courses. You have a piece of paper and there's a person doing the maths on the screen, and you're sort of listening and you're copying and you're listening and you're doing like you're going, so what the integral of that, and then actually you're not listening because you're looking and then you're writing and then you're looking and you're not listening actually, and they may as well not be saying anything, which means you're not picking up on all these nice nuances that the teacher is giving you. All you're doing is transferring the algebra from the screen onto a piece of paper, and that means that you're not listening, so you don't hear what they're talking about, and it also means that you're not getting any of this. Well, you're just literally copying it. Literally, you're copying it. Your brain is doing copying, not thinking, not learning. So the template notes match perfectly. I'll show you some in a bit. They match perfectly with the video, and for ultimate users, you can just print them off. They've got all of the maths on there. They haven't got the annotations. So what you're going to do is you're going to listen, you're going to watch, you're going to think. You don't need to copy it all down because it's already written down for you. But what you're doing then is you're annotating, and that annotation is a really, really, really good way of learning maths. Annotating solutions. So that's my next tip, annotating solutions. Don't have anything in your maths folder that isn't annotated, okay? There is no point you having pages and pages and pages and pages of paper with scribbles all over them, maths symbols and numbers. And you can't read that. No one's ever going to, you're not going to sit there going, oh, look, I did a question on, what does it say? 4x plus 2 equals, you're never going to read it. We find it hard to even read the maths that we wrote 30 seconds ago. How hard is it looking for mistakes? Really, really hard, because it's really boring looking at the maths you wrote 30 seconds ago and you just go blah, blah, blah. Yes, yes, yes. I am very good. Yes, it's all fine. So annotated solutions look like this. I shall show you an example of a template note with annotations on it so that you can see. And hang on, let me get this one out. This is just the first one. So I actually cannot see myself, so I cannot see whether you can see this. Rich, can you see this?
I'm currently actually looking at YouTube, so we're a few seconds behind. Let me switch over. Yeah, but you're going to stop screen sharing, Ronnie, because your preview is tiny. So just
got you.
off, you need to need full screen video so that we can see what you're actually holding up.
Yeah. Stop screen share. Better?
Let me go back to Zoom. Yeah, that's better.
Okay, so this is what I mean by annotated notes. Okay, so you've got the equation, and the equation stuff is happening, and no one's ever going to read that in a million years. This is what's important, this green bit, that you are actually thinking, what did I do from this step to this step? What did I do to both sides? Or what did I do to the top and the bottom? Or what rule did I use? And really thinking this through, you'll be amazed how difficult it is to do it. You'll do the maths, and then when you try and annotate it, you will think, oh, I don't know what I was doing. I just timed it up. There's no such thing as times it up, okay? Timesing it up doesn't exist. That is not a mathematical technique, timesing it up. So this will help your brain to really get in, like, what are the mathematical techniques that I'm using here? And then by doing that, by forcing your brain to go, I'm using this rule, I'm using this rule, it's another way that you're going to stop your brain making up rules, like the square root of two things added up is the square root of the two things added up, which is not true. Okay, let's go back to screen share, and then we can have a look. Share screen.
Maybe make the initial point on the screen share, Ronnie, and then hide it again. So you just kind of dip in and out. It's much nicer to see you than it is to just look at the lovely presentation you put together. But it'd be
well, fear not. My presentation is literally this long.
Okay, so
That's my
yeah, but
presentation.
read the
But
point
yeah,
out.
yeah, yeah,
You can
yeah.
send the screenshot off. So it's, yeah,
I
it's just
think,
way more
to be
engaging.
honest, I think that the other things are much more obvious. You need to do about 5 hours of maths outside class each week. You teach people whenever possible and ask questions on the course. Whenever a question occurs to you, you can just go straight on there and ask away and put your question in. Doesn't matter if it's 4 o'clock in the morning. Doesn't matter when it is. So these brilliant pictures that I drew show you what you're going to need. You're going to need a A4 folder and 4 pens, red, black, blue, green, for the different ways of making the notes, and dividers with 10 dividers down, and a million, billion bits of paper. Okay, and maybe pencils if you want. And that's what you're going to need. And then you basically, from that point on, you can just totally hand over to me and Taylor Tutors, and we will look after you and we will take you through that process. Right. My last thing before I turn into like talking to you and asking questions, asking what help you want with your homework and stuff like that, is this is the most important thing about A-level maths, is that we write algebraically, but we're not thinking algebraically. So that equation there that we write, and then we expand the left-hand side and we maybe move the 3x to the left-hand side, and then we refactorize it and we do something and we do something. Those algebraic steps that are happening are not what happens in the brain of a mathematician. What's happening in our brain is always a picture. We are led by our instinct, which is fed by the picture. So that equation down there, x plus 4 times x squared minus 1 equals 3x, looks like that. That's what it actually looks like. So I already know that equation has three solutions. There's another one off to the far left that I didn't draw. 2 of the solutions are negative, 1 of the solutions is positive. And you can see that in your head immediately when you look at the algebra. And this is what I would say is the big step from GCSE to AS. And also, if you manage to get yourself through AS without thinking in pictures, the big step from AS to A2. The further you get in maths, the less able you are to do it and less you are able to think in those pictures. So graph sketching, you shouldn't think of graph sketching as being like a topic. It is a topic, but more importantly, what graph sketching is teaching you how to read the algebra and think in pictures. Okay, that is all of my, that's good, 20 minutes. I wanted to do 15, but 21, that's not too bad. And I think I've talked through most of these things. The fact that you can ask questions if you're an Ultimate subscriber, and I'm going to get back to you really, really quickly. So you're lying in bed and you think, wait a minute though, if you have a graph that's a cubic and you do that, you can just literally open your laptop then type it in, and then you're going to get a response and we can discuss it. So really, really want to help you with your transition to A-level. Has anybody got any homework they would like help with? It would be good if I could see the chat, but I can't.
Yeah, okay. Well, I've got 2 questions that have come through so far. One from Pierre. Yes. What is the best way to make sure that you understand the topic? And we'll tackle that one first. Let me know. And then I've got one more from Armand when we're done with
that. Basically, think of it like learning a language. So I could teach you a word in Russian and I could tell you what that word is, and then you know that word. And what you're trying to achieve, but when you're learning maths, is a fluency. So an ability to use that word in lots and lots of different contexts. And it's one of the things that you realize when you're talking to somebody who's learning English as a foreign language, or you're speaking to somebody in a language that you're learning. It's really stilted, boring conversation. It's kind of like having a child conversation, because neither of you know enough words and enough nuances, and you don't have that fluency with the language to be able to pick the exact right word that you want, that you need to communicate at that time. And it's exactly the same with maths, that the more you use the concept, the idea, the technique, the more you see it in lots of different contexts. And the more you see it in different contexts, the more you have a more rich understanding of that concept and that idea. So you can't at the beginning, there is no way at the beginning to have that richness and that fluency. That's impossible. That's literally impossible. You have to develop it slowly, which is why in maths, it's practice, 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 practice. It's really, really like learning an instrument. You have to do your scales. You have to sit and solve a whole load of quadratics. And then that means that when you are out in the field of real life, which of course we all encounter quadratics in real life all the time, and then the quadratic comes up and you want to solve it, then your brain goes, oh wait, we've seen this similar thing, and it can go through and it can remember all of that practice that you did and draw out those skills. So it's about coming back to things over and over again, not learning a topic, moving on, learning a topic, moving on, which is the spiraling. That was written here, so a funny angle, sorry. That spiraling. So in the course, in the weekly classes, we're going to come back and back and back to the same thing all the time, and in a way that you don't need to worry about, because I've already sorted it all out, and that will mean that you never quite forget it. And just as the concept might be falling out of your brain a little bit, it gets pulled back and it gets reinforced by that forgetting and doing it again, and forgetting and doing it again. That is the best way to have long-term knowledge of a particular subject. And in maths, it's not the knowledge that makes you fluent, it's the experience of seeing it in a variety of contexts and tackling it in a variety of contexts. That's what it is. I hope that answers that question.
Yep. Second question was Armand. How much more difficult is further maths than regular maths A level?
That's a good question. I mean, it's not more difficult. It's more maths. So when you do further maths, you basically do 2 A levels. You do more topics. You do much more topics in maths. So you see a greater variety of maths. So you, depending on what school it is, you might see some decision maths, you might see further stats, further mechanics, or lots more further pure. So you're going to see more richness. Oops, that was falling. You're going to see more richness and variety in the maths, but that doesn't make it any harder. A lot of the stuff in further maths is just as difficult as C4. Oh, it's not called C4 and C3 anymore, as paper 1 and paper 2 from the A level. There is more, it's more fiddly algebraically. It's more fiddly algebraically, definitely. And there are a few things which really, for you to be very good at it, you need a conceptual understanding. So for example, 3D vector geometry, thinking about shapes in 3 dimensions and planes in 3 dimensions, and whether or not a plane intersects a line, and if so, what does that look like? And being able to move things around in 3 dimensions is quite difficult. You can still kind of get quite far with it, though, just by learning the techniques and practicing the techniques. So in that sense, I would say it isn't a lot harder. I think that the reason that some people who can do maths would not succeed on further maths is their algebra skills. When you do further maths, you need to just be able to manipulate algebra. You need to be able to talk fluently in algebra. And so that becomes much more important than in normal maths, where it is still really important. But in further maths, it's just expected that you can speak algebra, that you can manipulate algebra very, very quickly and not get tangled up. So in that's the sense in which I would say it's more difficult. And also the fact that you need to do 10 hours of maths a week outside class. That's a lot of maths. If you don't really enjoy doing maths, then that's a lot of maths. And it can be really hard doing maths because you feel like you can't do it a huge amount of the time, because that's what maths feels like. I can't do it, I'm stuck, I don't know what I'm doing. And then suddenly an idea, and then like, oh my God, it's really easy. And then you don't even feel clever then, because then you think, oh my God, I spent all day trying to do that and it was really easy, I'm such an idiot because I didn't. So maths can be quite psychologically draining, and but it's worth it. It's worth it for that moment when you see how to pull this problem together, and you see that if you just do this and take this path, then you're going to come up with this beautiful solution. Which is
challenging. That's like all of education really, is finding that. I remember a conversation Ronnie and I had towards the beginning, is like finding that optimal amount of challenge, so it stretches you, but that it is still possible for you to achieve. So you get the satisfaction from doing it. I don't know, what did you put it, Ronnie? The zone of optimal something or other.
Oh, yeah, I can't remember now.
Yeah, one of them. So yeah, like 2 + 2 = 4. Yeah. No challenge. If I give you a sum that is not possible to solve, there's zero interest in me. I'm not going to invest 10 hours in trying to solve this problem because I know that it's impossible. But setting me a puzzle it might take me half an hour to get my head around, but when I do, I know that I'm going to understand it. That gives you that those endorphins release. There's lots of biology as to why that feels good.
Yeah, absolutely.
But
I say it's like an analogy is hide and seek in a room, and say that you are training for hide and seek Olympic games in hide and seek, and so you're practicing, right? So you say to me, right, can you hide something, and I'm gonna try and find it, and then I say, okay, so I hide something, and you come in and you go, oh, can you give me a hint, can you give me a clue, like roughly where is it, roughly? And then I say, okay, it's in that corner of the room. Then you go over to that corner of the room and you go, like, can I have another hint? And eventually I end up more or less basically saying it's under that cushion. And then you look under the cushion and go, oh my God, I totally get it now. It was under the cushion. Yeah, I found it. I'm really pleased with myself. I'm really good. If you do that over and over and over, then at the point where you go into that Olympic Games of hide and seek and you walk into a room, how on earth are you going to know how to approach this problem? You've never, ever, ever done it, ever. You've just convinced yourself that you have found these things by asking somebody to basically show you where they were. And that's the copying homework thing. It feels like there's a very fine line in maths, which is why your teaching is so important, the teaching that you get, because there's a very, very fine line between helping somebody and actually doing the opposite of helping. And if a student comes and says they need help with something, you have to be able to help them to see their way through the problem, not just provide the solution, which is the same as what we were saying about exam solutions.
Yeah. So I'd say that students used to like me teaching them physics because I didn't really understand it natively. It just didn't make huge amounts of sense to me. So I had to kind of break it down and then explain it in a way that I understood it. And sometimes students who were struggling found that really useful as well. So a couple of quick questions then, Ronnie. Ria was just saying very nice things, asking about the web classes. In fact, just saying students, we had a question about how do you find your mistakes? Your silly mistakes in your maths work. I said you do a lot of work in that in your live classes, in your web content.
And absolutely. And every single video, every single one, the notes have this little tick symbol down the bottom, and it tells you how to check for mistakes. Every single video, everything that I do is not just about how do you do it. It's about, right now that we've done it, how are we going to see whether or not that's right? Because as people will see in my videos, because I don't edit them out because I think it's important, and in the live classes, I make mistakes. We all make mistakes. It's not something that we can stop doing, but it's something that we can learn to mitigate the effects of. So we can learn how to check our answers so that you know whether or not there's a mistake. And cleverly, if there is a mistake, you can use techniques to work out exactly which line went wrong. So you don't have to go through going, is it here, is it here, is it here? You can use these techniques that I'll teach to go, well, I know where the mistake is, it's from there to there. So now all I need to do is just check exactly what I did, which is why it's important that you get used to this annotation, because you think to yourself, what did I do then? What process did I use from there to there? Is it valid? Is it legitimate? Did I use it properly? And all of those things, they come together slowly and produce this fluency and this confidence with the material and with the algebraic structures and with the language that we use in maths and with the difference between what's on the page and what's in your head. All of that stuff comes together through this skill building.
Awesome, wonderful. So we had another couple of questions. Let's do, okay, so Ria's going to be resitting the old spec and just wanting to know how well the maths course will correlate to the new A level to the old A level. I think we may put together a little special course for people who are doing resits of C3, C4. Is that right, Ronnie?
Yes, because I've got the C3, C4 revision course from this summer. It's a revision course, it's not a teaching course. So the videos that are in the starter guide and the ultimate guide, that's much more sort of teaching the material, whereas the revision course was like, right, what do you need to know? I was assuming you'd already learned it because it was a revision course. But what I think would be a good idea for people doing resits is if we put that revision course in the ultimate bundle so that you can access just your C3, C4 revision, as well as seeing the other stuff if you need to. And I can just chuck a document together telling you what parts of the new A level are not in, so that you don't like see something and freak out and think, oh my God, because there's quite a lot in the new A level that wasn't in C3 and C4. So yeah, I think we can definitely, I mean, like email me, maths@tailoredtutors.co.uk, and definitely we can help you out, and I can make it super clear to you which bits of the new stuff you don't need. And
yeah, we can maybe
bits,
make a PDF or something, can't we?
yeah,
Ronnie,
exactly. It's very little taken out. The only thing that is going to be you're going to do in C3, C4 that is not in the new A level is volumes of revolution, and also modulus of functions that aren't linear. Pretty much everything else is still in it. So it's more that there are things in the new A level that weren't in the old A level rather than the other way around. But yeah, I can easily put a document together that makes that super clear to you. Or yeah.
So John added, was it zone of proximal development? I think that might be the right term.
Yes, I think that is exactly the right term.
To John out there. Akil asked us, do you think maths puzzle games like Sudokus increase maths logic or skills? And if maybe not Sudokus, then any other particular maths puzzles that may do that?
I hope not, because I can't do them at all.
Okay, we'll skip over that one.
It's a different part of your brain. I think there's probably a small overlap in the way that your brain solves those problems. But see, don't forget, when you're solving a Sudoku problem and those sorts of problems, you're actually following an algorithm that your brain has made up, and the algorithm will be more or less efficient depending on how much time you've spent doing it. But you're not actually being creative, you're following steps, and those steps aren't steps that you're going to need when you're doing maths. They're different steps, and you're not using any algebra, and you're using numbers, and we don't use numbers really in maths, and when we do, it tends to go wrong. So no, I think basically it's really boring, but if you want to be super good at maths, what you do is you get a textbook, or you go online, or I'm putting up lots and lots of question sheets all the time. You just do a whole load of them. You just do a whole load of quadratics, you do a whole load of finding inverse of functions, you do a whole load of that, you just do a whole load. It's like practicing the same piece on the piano over and over and over. And then when you come to a new piece, you bring with you all of this experience and knowledge, and you automatically apply that to the new piece of music or to the new problem. And plus it's fun, isn't it? If you solve a load of equations in a row, that's fun. That is fun. I'm going to persuade Rich that is fun this year. That's one of my targets.
I'll give it a go. I'll have an open mind.
When you start solving equations and getting them right, you're going to be like, this is really fun.
I never disliked maths. I could always do it. I was just, I don't know why. It never really clicked. I guess maybe it just wasn't natural enough for me to it just didn't quite ever just flow. It wasn't like a language to me. I had a question from Armand, another one saying, can I ask what the hell even is decisions in maths? I looked at the decision maths. Decision maths, yeah.
Yeah, I agree. What even the hell is it? Exactly. It's a weird, basically it's an introduction to a branch of maths which is not like the sort of maths that you do, like calculus, trigonometry, that sort of stuff. It's not like that. The problems that are solved in that area of maths are really very practical problems that people use all the time, but they're not the sorts of problems that you're used to seeing. They're not algebraic, basically. So, for example, that you would actually see, when you there's a works going on, and they set up they have like a little porter cabin, and they sort of work there for a while, the workmen, when they're building something. If you go in those porter cabins to where the workmen have their offices, you will see on the wall a Gantt chart. And what a Gantt chart does is it lists the jobs, and it takes into account which jobs have to be done before which jobs. So you can't paint the wall until you've plastered you can't paint it and then plaster it. And you can't paint it while it's halfway through being plastered. So painting has to come after plastering. Plastering has to come after construction. Construction has to come after the delivery of the wood and whatever it is that you're making the wall from, all that sort of thing. But then there's other things going on as well. And you have this big thing called, the topic is called critical path analysis, and it allows you to set up all of these jobs with all of their precedences, and then find a way that you can make the smallest possible amount of time where everything will work with its precedence is done before it. So that is literally how people set up big complicated jobs like this, and then they produce a Gantt chart, and then that shows you if this job is a day late, is that going to affect other jobs? Or if this job is 3 days, how late can this job go without it starting to affect our final deadline, which is when we said we're going to finish the project? So it's a really realistic problem, but it's not a sort of write an equation, solve an equation problem. So another one is Chinese postman problem. So you have a load of towns and they're all joined up with roads, and the postman wants to deliver things to each town. What route should he take? So shortest route through things. And can he get all the way around without going back down any roads that he's already been down? And if not, which road should he go back down to minimize the amount of time he spends walking? It's problems like that. So it's a different style of maths. It looks really weird when you look at the papers. There's like dots and lines everywhere and crazy stuff like that. But most students don't love it. It's not compulsory in further maths. You can choose it, or your school can choose it or not choose it. But you're right, it is a funny one. It is a funny one. But I've got videos on that too. If you want any help with that, that's no problem.
I was just halfway through typing. I had a couple of questions. People saying that they didn't get 8s or 9s at GCSE, and they may be concerned about starting A-levels in specific subjects on maths. So it could be obviously biology or chemistry. So any advice on sort of minimum entry level and how much of it you can make up with hard work and good practice versus, or is there some levels at which just point it may just be a bit beyond it? Also, that may depend on, were you just slacking? Were you, how did you get your 6 in GCSE because you were smoking cigarettes behind the bike sheds every maths class, or were you trying really hard and still getting 6s? I guess that might be an influence. Back to you, Ronnie.
Well, I've been teaching a long time, and in that time, I have had one student get a U, one, and that student was smoking cigarettes behind the bike shed a lot of the time. And basically I think, I might be wrong, but I think that anybody who wants to pass A-level maths can pass A-level maths. I really honestly,
I was saying the same about A-level biology. I reckon I could get, if you were prepared to do the work with me, I could get you at least a D.
Yeah,
probably.
Absolutely agree. So usually my students, when I've got a whole class of students, which I've obviously had lots of classes every year, I would expect about 60% to get an A, and I would expect no one to fail and no one to get an E. So yeah, I agree. At least a D, and then a few Ds, and then some Cs and some Bs, and then mostly As. Because if you understand how the exam system works, which I do because I'm a senior examiner for Edexcel for maths, and you understand how students don't pass, which partly comes from experience teaching and partly comes from experience marking, that when you're marking, you're going, wow, like students, this is why they're losing marks, because they're not doing this. And then you go, oh, I'm going to teach it differently. I'm going to teach it like that. Years and years and years of that building up, plus genuinely loving the subject and genuinely believing that any student can do well in it. That combination, it goes back to what I had on the slide, like students want someone to just tell them what they have to do, and that's what the Tailored Tutors course is doing. This is what you need to do. You need to come along to the weekly classes, interact with me, listen to what I'm saying, do what I'm saying, and you'll be fine. You will do well, definitely. I think if you have a 6 from, I think it depends. I think if you have a 6, you're going to have to work harder. But I had somebody last year before, and at the beginning, I gave everybody a test of GCSE algebra, and he got about 14%. And then a week later, we worked really hard together. A week later, he did it again, and he got about 14%. And then we worked really hard together, and then he did it again. And this went on for months. I mean, this guy was still getting less than 30% on tests of GCSE algebra in January of the first year. And he has just got an A star. And he started from that place. He started from a place where he just had no clue what was going on and couldn't do it, even though he was working really hard. But what happened was he persevered. And I persevered with him, and he persevered, and he's now got an A star in A-level maths, which is amazing. So yeah, I think basically, if you've got a 6 or a 7, then you need to be prepared to persevere and to put a bit more work in practicing and developing those skills and becoming more fluent. But absolutely, you can pass. Absolutely. I really believe that. I don't think I'm wrong in that. I think anybody who wants to and who has the right teacher can pass, definitely. And by pass, I mean do well.
We had a question from John. He says, what happens if you get the solution, but you do it in a different way from the mark scheme? Are they as picky as they are in biology?
No, not at
that
all.
wasn't quite the question, but I rephrased it to add the biology.
No. If you've solved the problem, then you've solved the problem. So long as you've done it rigorously, which means that each step was valid from the one before, and you haven't made up any rules of mathematics or something like that. You can't, if you've done a solution, what we do, the process is that if you're marking and you see a solution that you think, oh, this doesn't cover, the mark scheme doesn't cover it, then you send it up the chain. So it goes from the marker, they just send it to the team leader. If the team leader still isn't sure, they send it up to me, the assistant principal. And if I'm not sure, I send it up to the principal. And if your maths is sound, then you get all the marks. Whereas I know in biology, that's not true. You can give true answers and not get all the marks, which I just think is beyond me. How is that even possible? That you can say an answer which isn't wrong, but not get all the marks? No, in maths, whatever answer you go with, sometimes we have amazing answers from students. We're just like, what are you doing? And we all look at it and we discuss it and we go, what are they doing? They've got the right answer, but what on earth have they done? Because they've got this and this. And then someone will go, oh, I know what they've done. They've done this and this and this and this. And then we work it out and then we go, oh, you're a genius. And we give them all the marks. Yes, definitely. All the marks.
There's a question here that I'm typing an answer to that I don't exactly know how I'm going to finish it yet. So I'm going to put it to you whilst I think about it some more. He said, would you say that someone gets a 9 in Maths GCSE would easily be able to get an A star if they put in easily? I'd say no, but okay,
no, definitely not. Definitely not. I mean, the new GCSE, the 9 and the 8 and the 7 and the 6 thing, that's only been going a little while, and I think teachers are still getting used to it. And that kind of crossover, when the spec changes, there's a kind of a weird crossover where everyone gets used to what this new specification is like, and the exam boards get used to assessing it and all those sorts of things. But I have found in my experience teaching students coming into the AS with a 9 that it doesn't mean that I can predict how they're going to cope with the A level, because I think that there's an element of fluency that you, so for example, somebody with a 6, let's say they did all the algebra right, they don't know any shapes, they hate statistics, they don't do any statistics, they make mistakes all the time, but all their algebra is perfect. They can do all their algebra and all their graph sketching totally fine, but none of the shapes, none of the reflections, none of the real life stuff, anything that mentions real life, no chance, all of that stuff. That person is going to be much more successful than somebody who has managed to scrape a 9 or get into the 8s by being really good at mental maths, really good at problem solving, like the ones they put in GCSE with all the words and all that sort of thing, but can't do algebra. So they've dropped the marks on the algebra, but still managed to get the 8 or even the 9. I'm not even 100% sure. I used to know with the GCSE, with the A star A, exactly how much algebra you could get wrong and still get those top grades. Whereas I don't know that with the new spec yet. But it's the algebra, it's the fluency with the algebra. It's the ability to think and then use algebra to solve a problem. That's what you need from the GCSE. And I mean, I hated GCSE maths. I didn't like it at all. I just thought it was boring and nothing. I got nothing from it. And I think a lot of students, when they take that step from GCSE into the AS, they realize that difference, that it feels like a different subject. And some students love that. Some students just completely excel in this environment where everything's rigorous and tight and all your arguments have to be perfect and your algebra has to be perfect, and they love it. And other students think, oh no, I liked reflecting shapes and solving problems in the real world and all that sort of variety of GCSE. So I think I think hard work, it's a subject that requires hard work, definitely, for everybody, for sure. But don't let your GCSE grade define you, is what I would say. Rich, you have a question?
Yeah, okay. So I was going to say that I'm the kind of student that I was not a natural mathematician, and but I was smart enough to be able to just do the bits that I needed to do. And if I'd given it a bit more focus, I'm sure I could have learned enough sort of rote learning and just done enough practice to get me through it. I say get me through. I probably could have got an A star had I really given it my all. I worked as hard as my sister had done all her subjects. But if I had transitioned into Maths A level, I think I would have been, because I would have been kind of struggling to get an A star. Like, it would have been mostly me just using my memory to haul me through, as Ronnie was saying, using other parts, exploiting the parts of the spec that you do well at and just nailing those. And then there'll be areas that you're not quite so good at that you just kind of get away with. I think I would have been shown up had I decided to do A-level maths. And so it's sort of definitely no guarantee. There was a couple of great comments in the chat from people who were saying that, there's lots of students that they know who started with A's and A stars at GCSE and have come out with B's or C's or D's even at A level, and vice versa. People have gone in with C's and D's at GCSE and come out with A's and A stars at A level. If you most of it is your not necessarily your just ability, is your attitude, and you've got to practice. Nobody's ever going to learn anything perfectly well without practicing it. So if you're naturally talented at something but you don't put any of the practice in, you're going to make all those silly mistakes in the exam, and
Absolutely.
You might drop enough marks to drop you down from an A star to a B, which is just effectively through carelessness and not quite enough dedication into the practice in the build up to the exams.
Yeah, so, and also I think often for students that come into the AS Maths with a 6 or a 7, they're so aware that they might find this difficult that they actually start to use and employ good study habits right from the beginning, in a way that a student, like I got an A at GCSE, this was before A stars, I got an A at GCSE, I did nothing. I did no work at all. So when I started the A level, I didn't do any work, because my experience of maths exams is that's the only reason I took the A level, because I thought I'll just get a good mark without doing any work, and I was really, really lazy, and that's how I chose my subjects. But I think it is what, Rich, I totally agree, the attitude that you have towards it. If you are willing to persevere, I think perseverance is the big word that you need in maths. If you're willing to practice and you're willing to persevere when you're finding it difficult, and you've got the right teacher, then you're going to do great. If you go into it thinking, I'll be all right, I'll wing it at the end, it's fine, then maybe you can. Maybe you can wing it at the end. But more likely, you will get to, we work with these students all the time, don't we, Rich, that find tailored tutors in sort of March, April, and are crying and saying help, and I've never got D's and E's and I need a B to get into uni, and can you help me? Is it too late? And yeah, we do work with those students, but it's better if you start at the beginning.
Yeah, absolutely. Last year we sent out a whole load of sort of promotion and marketing, and then like getting people into this time of year in September, and then we did October and February as well, and then again in April. And these same people had received those emails, and so I've only just heard it. You've only just told me. It's like, no, you just didn't open the email in November. So we did email you at the beginning of the term, say it's probably better if you start now. And then they email us in a mad panic. Oh my God, I've only got 3 weeks to go, and I need to get a B, and I'm currently getting D's. Can you help me? And we'll do our absolute very best, but it's definitely best to start right now if you can.
And I love the relationship we have with the students. One of the things that is really good, I mean, I've been teaching full time forever, and what we're doing now with tailored tutors, what I'm doing now in this job, it's still teaching. I'm having that relationship with the students, and I can list off the names of the students who were with us throughout that revision period last year, came to all the lessons, asked loads of questions, put loads of questions on the course. I helped them out, and we really did. We're chatting away on Instagram now, some of us, because I will miss them loads, because we work together a lot, and I was really, really proud of them when they did well. Really proud.
A quick housekeeping. Is it Fatma, not Fatima? Fatma asked about is it better to get the ultimate guide for all 3 subjects or the all access pass? The all access pass, just to know, is like at revision time only. So throughout the year, it's just going to be a subscription. So you can have biology, you can have chemistry, you can have maths, you can have biology and chemistry, you can have chemistry and maths, or you can have biology, chemistry and maths. All of those things are going to be ongoing subscriptions that are going to run throughout the year. So
yeah, but I mean that ultimate subscription, I mean, essentially you're getting private tuition, sort of. But it's kind of better than private tuition, I think, because you can put those questions whenever they occur to you. You can just put those questions up. You can see other people's questions. So you can see the sorts of questions that other students are asking. Whereas if you have a private tutor, you don't get that to see those conversations, those interactions about what other students are thinking. You might read those questions and think, oh yeah, good point, actually, Rich.
And it also covers the whole course. When I was teaching students, my average bill at the end per client was about £3,000 at the end of the year. Some would start with me right in the beginning of September. Some would join me right at revision time in April. But I was generally fully booked, generally from the end of Feb, typically speaking. But that's how much. And I would, with 1 hour per week, even from the beginning of term, you can't one-to-one go through the entire spec. So they're paying all that, £3,000+ for me to be their one-to-one tutor. And I cover, maybe, if you start with me in the beginning of term, maybe I cover half to 3/4.
Yeah, so because teachers have 4 or 5 hours a week and struggle to fit all the content in.
Exactly. So like with this, you can go to it anytime. We've done lots of research with the students, and like you can do it anytime. You can rewind it, you can pause it. Also, it avoids that embarrassing, like someone's explained it to you, you've done it in class, you've read the textbook, your tutors explained it to you. It's like, if you still don't get it, it's embarrassing to say, I still don't get it. Whereas you can just go back to the video and watch it, and maybe that 4th time, bang, it's just like, oh, it does make sense to me. Now I get it. So we had a couple of questions that whilst we were getting a bit off track there, Sebastian asked us, I think maybe you mean pure.
Seb's been here all week.
Yeah, so what is the difference between core maths and applied maths? I guess you mean probably pure maths and applied maths, or is there a difference between core maths and applied maths?
No, core maths is pure maths, and applied maths is statistics and mechanics. So in the applied maths, you've got problems that are in to be honest, they're not always in a real life situation. You could have a sort of abstract problem about a force acting on a particle, and it's not mentioning a car or anything else. But the mechanics is about how things move and why things move and how things slow down and speed up and why, and how long it'll take something to get somewhere else, or what would happen if I leant this ladder against a wall, would it slip, and all that sort of thing. The statistics is really, really interesting, actually, much more interesting than GCSE statistics. And it's sort of things like, so say me and Rich claim to be psychic, and I have some playing cards, and I have 10 of them. Yeah, exactly, Rich. That's Rich. You need to make.
They can't see me because I wasn't making any noise. I was
doing his psychic.
My psychic.
Exactly. So if we do, say I've got 10 cards, and then I'm going to communicate to Rich what their suit is. So he's got a 1 in 4 chance of guessing correctly, and a 3 in 4 chance of guessing incorrectly. So we would expect, if I did 10, we would expect him to get a quarter of those right, so about 2, maybe 3. Right, say he gets 5 right. Does that mean we're psychic or not? And that's what you learn to do in the statistics. That's hypothesis testing, and that's what you learn to do. It's really, you do it properly. So we can not prove, but really, really understand that scenario. Like if I have got, this is really important, if I've got a new drug and I give it to all these people and this number of people, get better, does that mean the drug is working or not? Could that be a fluke? And you investigate that sort of probability, and it's very applied and it's very interesting. And pure is more calculus, trigonometry, straight lines, proof, stuff like that. Rich.
Biology application here. So I answered
putting your hand up to speak.
Well, it's because you can see me with put my hand up, and I don't have to talk over the top of you. Yes. So yeah, a biology example on that. Well, a student asked me a question about genetic drift, which is basically when you have a really small population of, let's say, you've got a few males and a few females, and they get isolated somewhere. Random fertilization means that random chance has a much bigger influence on that population than a massive population. So if you have, let's say, you've got 3 dice, and you roll them simultaneously, you get 3 6s. Chances of that, well, we could work them out, couldn't we, Ronnie, as well?
Yes.
1 times 6
cubed.
1 over 6 cubed, exactly. I was just about to say that. But if you had 3 million dice and you rolled them all simultaneously and you got all sixes, obviously there's much less chance of that happening. So
6 to the power of 3 million.
There you go. There are
basically
exactly the numbers.
zero.
Yeah, more or less zero. So like those random
but not
chances,
impossible. This is the thing.
but not
this
impossible.
This is what we learn in hypothesis testing. There's a really good what's his name? The guy who Darren Brown, and there's a scene where he does something where he I'm not sure whether it's a dice or a coin, and he gets head, like over and over and over. So he's like made the coin go into like 100 heads in a row or something. I don't know how many it is, but it was one of those series where he was explaining what he was doing. He sat there for days and days being filmed flicking this coin until he got however many in a row, because you would eventually. It's just because a coin is fair does not mean that it's impossible to get 10, 15, 50 heads in a row. It doesn't mean it's impossible. So if I get 50 heads in a row, if me and Rich do the psychic test and we get 5, he guesses 5, 6, 7 correctly, could that be a fluke or not? Well, yes, it could be a fluke, definitely. But what's the chance of it being a fluke? And then you make that decision. You say, okay, if the chance of this happening as a fluke is so small, I'm going to assume it wasn't a fluke and that actually there's something going on here. There's actually a psychic connection, or there's, the coin is being affected by Darren Brown or whatever it is. So yeah, the statistics I think is much better at A-level than at GCSE. Who cares about the mean, the mode and the median?
I cheated in some of my videos. Because I was doing coin tossing, because it's about homologous chromosomes and it's 50-50 as they go to one left or right. And I just got our video editors to I just tossed the coin a little on the page, and I just had them cut. So I just managed to manipulate. In fact, I think it was actually even the video on genetic drift where I was doing that just to demonstrate how random chance can affect the two different populations.
So to demonstrate random chance, you cheated and random chance.
No, it was to demonstrate how, I can't really remember. I was tossing coins and I definitely manipulated it in some way because I wanted to prove a point about if you get 3 heads in a row or something weird. There were a couple of quick questions, since you can't see the chat there, Ronnie. And we should probably start rounding things off as well. Luke just put this out to the group, not for you to answer, but to the group. What did people get at GCSE who was going on to do medicine and dentistry at A-level? So any of you A-level students or people doing applied for the UCAS, or anyone finished their A-levels last year with TT, you can answer Luke there. Does anyone know which universities don't require biology for medicine? I don't know. I would say it's biology. You should do it because it's totally awesome and amazing. It's quite a lot of hard work, but it's really fun. Abdiaziz, I think it is my name, the guy with the funny mustache, the funny looking mustache. I don't know what's so funny about it, but yeah, my name's Rich. So you can say hi to me if you're going to do any biology stuff. You covered it so well. Most of the time it was way better than my actual teachers. Well, that's nice to know.
Look at that. You've managed to hijack my maths one with your biology one.
All right. You did like 10 minutes of maths last time. How is Ronnie able to think of numbers just from the top of her head? Genius confirmed from Sebastian. Ria had answered some of those questions. I'm just trying to catch up because, okay, so some people asking us about the coupon. The coupon is try it free. You can just buy a course using the coupon, try it free. It will be there until the end of September. Is it 30th or 31st at midnight? That will be invalid. So you'll just start a subscription as per usual, basically, at that point. Do you think TT should be used if you're not falling behind in maths or not failing in maths?
Yes, because you don't know. You don't know that in maths, because this is the thing, is that when you go to the lessons and you hear the new content, you do understand it, and you can feel like, I'm sure, I can't see the chat, but if anybody's in the chat who did AS or even the A2 last year, I bet they will confirm this, that you can feel like you're doing really, really well, and then suddenly you do a past paper. In fact, weren't we talking to someone the other day that came into the Zoom chat on Monday about this in maths, that she was saying she thought she was doing really, really well. She did a mock exam like March of the second year and got a D, and had no idea why, and didn't know what it was that she wasn't doing. And what you're getting, this is what I put on that initial slide, what you're getting is that reassurance that if you follow along from the beginning, then you're pretty much guaranteed that good grade. You're pretty much guaranteed it. I think I've taught enough students and got enough results to be able to say that honestly, that you can pretty much guarantee those good results if you work with me all the way through, definitely.
There's a few combining factors. There's sort of some natural ability of some sort. There's also your how much work and your attitude towards the work. And what I was going to say something else. I've kind of forgotten what that extra thing is. But basically, yeah, your approach and the things that are in your control are the most important factors in how well you're going to do. Some people have to try a little bit harder to get those top grades than others, and that's just the way of the world. But there's definitely the things that are within your control, how much work you do and which examples you do and how you approach it. Just doing hours and hours and hours of study isn't always the right way of doing it.
Yeah, absolutely. Absolutely.
Time and effort are not necessarily equal in terms of weighting, in terms of getting you the marks on the exam. It's something we really try to focus on.
And it's one of the things,
doing the enough work, but you're doing enough of the right work, using your brain in the right way to test yourself. Those maths notes in the template notes for the maths course is a great example of that.
Oh yeah, we haven't actually
totally differently for biology and maths, because the skill in biology is learning and remembering the content. So we don't give you any of that. You have to write that down because that's what's going to help you remember it. In maths, the numbers, the actual numbers are almost irrelevant. It's the processes and those linking, the annotations that Ronnie was going on about right at the very beginning that's going to help you understand the process. Ronnie, also, what did you have next to the door when you were teaching? What was the object that people put their notes in as they left the classroom?
The bin, the recycling bin. Yeah, this is, I mean, I put this on, I think this was third down on my tips. Like, there is, if you're learning the violin, would you, every time you practice the violin, put a tape recorder, because that shows how old I am, you probably use like QuickTime or something like fancy and modern. But anyway, would you record every time you practice the violin? And then would you sit there going, oh, I better listen to it? No. You don't need to keep anything that has mathsy squiggles on unless you are willing to annotate it. If it's that good, if it's a good example and you're willing to sit there and get a different color pen and at the side, right, I did this, this was the method this was how I was thinking through the problem, this is what I was using at each stage, put that in your folder. The rest of it you put in the recycling bin. Or even just work on a whiteboard. I know loads and loads of students that buy a cheap whiteboard from Ryman's, you get 10% off if you've got a student card. Buy a cheap whiteboard like this and just do all your maths on a whiteboard. And then it just rubs out and it doesn't matter, because it's one of my favorite things is like, if I say like, I'm not going to collect your homework in this week. I will go through any problems you've got, but I'm not going to collect it in because I'm doing all this other stuff at the moment, and I'll collect it in next week, something like that. And then the students go, oh my God, I wasted so much time doing that. That was such a waste. Oh my God, I can't believe you're not collecting. Like, that's the point, is that you only learn you learn from doing it. It doesn't matter if you do it on a whiteboard and rub it out, or you do it on a bit of paper and chuck it in the bin. It doesn't matter. Good,
that kind of ties back to
what the ones with the annotations, but you only need a few of those.
It goes back to what you were saying earlier, like, what's the purpose of doing it? Like, just copying. Like, copying comes with a lot of stigma, but like, just photocopying the textbook. People ask me for the printed out, the full notes from my biology course all the time. It's like, the information already exists in the textbook, in my, like, you're not trying to replicate it more for the universe's sake. Where do you need it? It needs to be in here. The process of doing the work yourself is the thing that makes you learn it. So no matter how, if I give you my folder of all of my notes, what use is that to you? Okay, yes, if you use it to copy from, then you're gonna build those things into your brain, but the process is what's so important. And like, something that we're really trying to focus on is just to give students the right tools so that they can help themselves with our help, basically.
Yeah.
And Ronnie, let's say just a couple of minutes, let's tie things off a little bit. I think
do you want a little probability problem?
All right, you can do a probability problem. Is it a puzzle, or is it just
no, it's a sort, I don't know what you would call it.
Yeah, you might already know. Do a little bit of a probability problem.
I don't know if I've already told you this one.
Ooh.
Okay.
I'll pretend not to know, so then when I get it right really quickly, I'll just think.
Well, even if we've done it, to be honest, I think you'll probably say, oh, we have already talked about this, but I still don't get it. Because it's a really, really good example of how instinctive statistics and probability problems and actual probability are not the same thing. And we have to learn, statisticians have to be so good at using rigorous mathematics to think about probability, which is kind of weird because you sort of think of probability as being things that may happen or may not happen, and the extent to which things may or may not happen. But actually, it's a really, really rigorous part of mathematics to study, and it's really, really.
Is it the birthday paradox?
No.
Okay. I know that.
Okay. Here's a box. There's 3 boxes. Okay, ABC boxes.
Yep, I'll be the voice of the YouTube massive on this one.
Yeah. This is for you. One of them has a car in it. Okay. The other two, yeah, you like cars, good. It's got a really good car in it, and the other 2 have a goat in them. Okay. Right. Yep. Which one would you like?
I don't think at this stage I've got no information to work on, so I'm assuming it's not going to make a difference. I'll go alphabetically with A.
You want A? Okay, so you've chosen A. Okay. Yep. Right, I'm going to tell you something.
Okay. Is it got a car in it?
No, I'm not telling you that.
Oh, that's what I want to know.
No, I'm going to tell you this. CC.
Yeah.
C had a goat in. That's a goat.
Yeah.
C had a goat in.
Oh, yeah.
Right?
Okay.
So that's good to know. All right.
Yeah. Yeah.
Do you want to stick with A, or do you want to change to B?
I feel like there should be a really clever solution to this, and I should be able to see it. But I actually no regrets. I'm gonna stick with my guns.
Yeah.
What are people on YouTube saying?
Yeah, what are people on YouTube?
Yeah, okay, Ria, you're quite right. I think Ria's definitely. She's saying that I should switch. Because initially, well, in fact, I'm gonna stick by my guns, and you're gonna teach me by example, because I'm probably gonna be wrong. So I'm gonna stick with A, and you can explain.
Why is Ria saying you should switch?
Because she's saying, and I see that initially my odds were 33% or 33, 1 in 3.
Yeah.
And now my odds are 50%. So
yeah, but surely it's still 50-50 A or B. So surely it's still completely.
Well, that was my logic. It's just as likely to be A. I'm going to go with A because my brain is boggled, but I have a feeling that I'm probably wrong. Or I think Ria is good. You should switch because the probability that it has a car is 2/3. No, it can't be 2/3. Put me out of my misery, Ronnie. There's lots of stuff going on in you.
You statistically, at this point in this game, the car is more likely to be in box B than box A because of the information I've given you.
Okay, so
by sticking, you are reducing your chances of winning. It is now, because I told you what was going on in C.
Yeah.
It is now more likely to be in B. It makes no sense, does it?
No,
but it's true.
Yeah. Are you going to tell me why?
Oh, why don't we do that next week?
Oh, tenterhooks, I like it. Okay, for the solution to the box puzzle, or maybe we could do this as a little theme in our web classes. We can set a little puzzle at the end of the week. It's a good puzzle because it really does make no sense. In your head,
nothing's changed. The initial choice is 1/3, and the second choice is 50-50, and then you just think, well, I'll stick with what I thought initially because we sort of make up this thing that we have some insight, and then we'd be annoyed if we changed and we didn't, So, but no, it is that by me providing that evidence, I'm giving you the information that the car is more likely to be in B, and I can explain why next week.
Okay, perfect.
Cool.
There's consternation out there.
I can't see the chat.
People are wanting to know, but I guess there's a solution to that. And it's see you next time. So we had a question about you and Millie, who's Ronnie's daughter, is doing a maths degree.
Yes. She is going to be coming on next week. Hopefully, she was going to do today, but she's really busy packing because she's moving back up to Leeds to finish her degree. And she and I are going to show our university notes and talk about the way that I recommend making A-level maths notes and the way that we made university maths notes. And she's going to talk about her experiences of going from AS to A2, going from A2 to degree, going from GCSE to AS, because obviously that's far more recent than mine, which is quite some time ago, and hers was more recent. So yeah, Millie's going to come. She was going to do tonight, but she's super busy, so she's going to come on next week, hopefully.
Okay, great. So, and other bits and pieces from us. Loads of people asking about the Instagram channel as well. So yeah, check out the Instagram channel from Tailored Tutors. It's just Tailored Tutors, one word. I'm pretty sure, I really should know that, but if you search Tailored Tutors, you will find it. Lots of revision tips, study tips. There's biology, maths, and chemistry A-level bits and pieces in there. Lots of like key terms and things to remember, essential, nice to know things.
Yeah, and I want everybody, like, I love doing maths, right? So, and teaching maths. So what I want is everybody to just go on Tailored Tutors, make an account. You can use Try It free. You can get a whole month for free, and just look at those maths videos and whack some questions on. Ask me some questions. I can help you out.
Yeah, you've got the services of the assistant principal examiner for your subject who is offering you free help for the month. I would take her up on it. What other bits and pieces? Yeah, if you want to make sure you don't miss any more of our YouTube-y, live-y type things, which are happening every Monday to Thursday throughout September, hit the bell to make sure you get those notifications when we are online. It's going to be basically 8 p.m. Monday, Tuesday, Wednesday, Thursday each week throughout September. Mondays are going to be basically for everyone. So in fact, Ronnie's doing a bit of physics intro on
Monday. I'm doing that on Monday.
Well, I mean, Ronnie may be a bit busy actually. So if not, I'm going to step in and do some. I'm going to be doing some ding ding dong science with Rich. I'm going to sort of give you a little bit of a probably 20 minutes or half an hour of some of the more interesting sciencey stuff that I've done. Some of it biology, some of it will just be general interesting science that I've just come across. And those of you that are interested in such things can join in, ask me questions, and drop into that live. And then Tuesdays will be biology, Wednesdays will be chemistry, and Thursdays will be maths. There'll be subject specific and all things that are sort of useful that you're going to need to know starting the new year. I might do some of my comment replies in video form as well as my text. So like people who are asking me questions on my course, I can just log on and then sort of give you the answers to your questions. Sometimes, especially with concepts in biology, it's really difficult to type. Well, you've got lots of tight terminology. You need to know what a homologous pair is. You need to know what the centromere is and how it's different to the centrioles. And if you writing out an answer where you like put all that in, it's like a paragraph to answer what's relatively simple question, but you just need to make sure you cover all the bases so you know where the student's going wrong. Any other questions? How much is biology for the year? It's a monthly price. So there's two options. Any of the single subjects are the starter guide videos only are, again, if I'm going to go year 13 prices, 29 and 49, year 12 prices are 19 and 39. So check out the website, tailoredtutors.co.uk/subscriptions for all of that stuff. Yeah, anyone who's sent us an email recently, we got, I think 200 plus emails a day right now. Travis is frantically his keyboard will be worn out by the end of the week. But yeah, he will get back to you as soon as we possibly can. If you want to jump on the online chat, we're there 6 p.m. to 9 p.m. on the website. So tailoredtutors.co.uk, pull up the chat and you can ask Travis questions live. If you're really waiting to get an answer on something, then he can do that for you there. I think, so there's just chat about the probability question. Tune in next week. I'll get put in my place next week. I think that's more or less all the bits and pieces. So we'll see you next week. No, we're not here tomorrow, guys. Fridays are a bit Friday evenings. We like our Friday evenings just as much as you do, I'm sure. So yeah, we'll probably be drinking a glass of wine probably and not on YouTube at 8 o'clock tomorrow.
I'll be nursing my new piercings.
Oh, what are you getting done?
No, I've done it.
Oh.
I've done it. I did it yesterday. Can you see it?
I can see it. Yeah.
I've got two there.
Well, there you go. I look forward to seeing them in person next time.
That's what happens if you go out with your daughter and you drink lots of wine and you live in Brighton. Then you go and get your ear pierced. But I do really like it. I'm really excited about it, but it is a bit sore. And if I turn over in the night, then I wake up because it flipping hurts. But yeah, I'm quite excited about my new arrivals.
Sebastian's just asking if you're an Ultimate Guide subscriber and you ask comments on the course, how do you get your answer? 99% of the time, you're going to get a typed out answer in reply, and that way, everyone else with Ultimate Guide users can see other questions and all the answers. So just general use of the comments, read the other questions first, because often, certainly of the biology course, which has had questions on it for a couple of years now, usually there will be a question that's maybe asked what you've wanted to know. If not, and you've read through those things, then just shoot me a question and I can give you all the help that I can. I think that's about it. So let's say farewell, shall we? It's just nearly 20 past. It's probably about time for knocking it on the head. Thanks again for joining, everyone. It's been super nice hanging out with you guys this week, especially those guys who've come back time and time again. Do feel free to spread the word. We are here, going to be on YouTube, absolutely free, zero commitment. And if your friends want to try it out, obviously they can just give them a coupon and they can just use it for the month and just show them how effective it's going to be. See you all on Monday.
Yeah, see you Monday.
Thanks, Ronnie. See you soon.
See ya.